As December 19th, 2025 approaches, a mysterious object called 3I Atlas is making waves in the scientific community. What seemed like a simple comet has turned into an enigma, one that defies all our expectations. We're here to explore not just what happened in the past, but what might unfold in the coming days. Buckle up for a journey through space, time, and the unknown. In the summer of 2025, astronomers detected something extraordinary hurtling through our solar system. It wasn't the first time an object had arrived from deep space, but this one was different. This wasn't just another stray rock or comet passing through the inner solar system. It was 3I Atlas, an interstellar object from another star system, and it was heading straight for us. The designation 3I was immediately significant. It stood for Third Interstellar Object, a classification used for the rare visitors from outside our solar system. The first two interstellar objects, Oumuamua and Borisov, had already shaken up our understanding of space, with Oumuamua's strange, elongated shape and rapid acceleration, and Borisov's typical cometary behavior. But 3I Atlas was different, even before anyone knew exactly what it was. The first signs of it came in early July 2025, when it was picked up by ground-based observatories. The Atlas Survey, a network of robotic telescopes designed to scan the sky for potential threats, noticed an object that seemed to be moving unusually fast. This wasn't your typical comet or asteroid. Its trajectory wasn't bound to the sun. It had a hyperbolic orbit, meaning it was only passing through, not lingering. This told scientists that the object had travelled from another star system, perhaps hundreds or even thousands of light years away, and was on a one-way trip through our solar system. For astronomers, this was a jackpot. Interstellar objects were rare and valuable, as they provided an unprecedented opportunity to study something that wasn't a part of our own solar system. They weren't just the usual icy or rocky bodies formed around our sun. They had been born around another star, far outside the bounds of our familiar environment. The data about 3I Atlas could reveal secrets about how other stars form planets, and how life might evolve on distant worlds. What stood out from the beginning, though, was its size and speed. It was travelling at an extraordinary velocity, faster than any object that had been detected before. The initial measurements put it on a path that would bring it within 1.4 astronomical units of the Sun, just a bit farther than Earth's orbit in late October. But as its approach continued, something about the object felt off. At first glance, it seemed to be just another comet, a typical icy body whipping through the solar system. But astronomers were quickly realizing that 3I Atlas wasn't behaving like a comet at all. Comets, for example, are notorious for being messy and chaotic. They are often described as dirty snowballs, composed of a mixture of ice, gas, and dust, which evaporates and releases gases as they approach the sun. These objects are unpredictable, constantly shedding material and forming tails as the heat of the sun breaks down their icy core. They often appear fuzzy, their structure dissolving into a hazy cloud of gas and dust. But 3I Atlas wasn't following this script. Instead of a random, disorganized burst of activity, it seemed to have a calm, precise trajectory. It wasn't scattering gas and dust in every direction. It was maintaining a steady, controlled path, as if it was intentionally avoiding the chaos that would be expected of something in its position. As astronomers continued to monitor its journey, they started to see something even stranger. The comet's tail wasn't forming in the typical way. There was a clean, defined shape, and the object seemed almost unnaturally stable. What made it even more puzzling was that as 3I Atlas neared the sun, its brightness didn't spike in the expected chaotic way. Instead, it remained steady, almost too steady for a typical comet. This sparked the first real questions. Was 3I Atlas a comet at all, or was it something else entirely? Theories started to bubble up, ranging from ideas about unknown cometary behaviour to speculations about extraterrestrial technology. But as the object continued its journey, it became increasingly clear that 3I Atlas was no ordinary comet. Its behaviour was unlike anything astronomers had seen before. This was just the beginning. The real story began to unfold as 3I Atlas approached the Sun, and more data started pouring in. With every passing day, the mysteries of this interstellar object only grew. Something about it felt as though it was defying the laws of nature. Could it be an intelligent craft, a probe from a far-off civilization, Or was it something even more unimaginable? As we'll see in the following chapters, 3 Atlas would soon reveal even more bizarre behaviours that would continue to confound our understanding of space. As the summer of 2025 drew to a close, the world was on edge waiting for more information about 3I Atlas. Professional observatories were gathering data, but it wasn't until an unexpected source, an amateur astronomer in his backyard, provided the first truly shocking image that the mystery of 3I Atlas deepened. Paul Craigs, a skilled but not famous astrophotographer, had been following the trajectory of 3I Atlas through his small telescope, the Dwarf 3, a piece of equipment commonly used by serious hobbyists. Craigs wasn't expecting anything out of the ordinary. His goal was simply to track the object as it neared its closest approach to the Sun, but what he captured was far beyond anything he could have imagined. At first, Craigs thought he'd made a mistake. His equipment wasn't as sophisticated as NASA's Hubble or the James Webb Space Telescope, so why would his image be any different from the ones taken by the professionals? But when he analysed the photograph, something caught his attention. The object in his image appeared structured. It wasn't the fuzzy, irregular shape typical of a comet, nor was it the blur of gas and dust he had expected to see. Instead, 3I Atlas appeared with sharp, clean edges, a brilliant white core surrounded by a glowing blue halo that resembled an energy field more than a comet's typical coma of gas and dust. Craigs posted the image online, not expecting much, but within hours it had exploded across amateur astronomy forums and science communities. Experts weighed in, but they were divided. Some suggested it was an overprocessed image, perhaps a glitch or an artifact from his telescope's sensors. Others, however, were stunned. This was not just a comet. This was something different, an object that looked far too organised, far too deliberate. What made the image even more compelling was that it wasn't the only one. Over the following weeks, other amateur astronomers with similar setups began to share their own photographs of 3I Atlas, and they were seeing the same thing: sharp, well-defined images of the object that didn't match the expected blurry, chaotic look of a comet. This added weight to the theory that maybe 3I Atlas wasn't just another comet passing through our solar system. Meanwhile, official images from NASA's most advanced telescopes like Hubble showed 3I Atlas as a much blurrier object, more consistent with the expected behaviour of a comet. But these images, while professional, lacked the definition and clarity captured by Craigs. How could such a simple, small telescope manage to capture such a precise image, when the most powerful instruments in the world failed to do so? This question began to fuel the growing speculation that the true nature of 3I Atlas might not be what the professionals were telling the public. In the month that followed, Craig's image and the follow-up photographs from amateur astronomers began to garner the attention of the scientific community. Something was definitely off about 3I Atlas, but no one could quite put their finger on it. Was this just a strange comet, or was there something else entirely at play? This question lingered, and more discoveries started to surface, each more baffling than the last. But perhaps the most disturbing realization came when the data from professional telescopes, which had once dismissed the image as a processing error, began to show anomalies that couldn't be ignored. More questions arose. Questions that challenged the very foundation of our understanding of comets, of interstellar objects, and perhaps even of what was possible in the universe. As we moved closer to the critical December 19th date, the scientific community found themselves grappling with the possibility that 3I Atlas was not a comet at all. Was it an object crafted with purpose, something we didn't yet understand, or was it merely a cosmic fluke, one that had bent the rules of natural physics in a way we hadn't anticipated? The answers seemed elusive, but what was becoming undeniable was the fact that 3I Atlas wasn't just passing by quietly. It was making its presence known in ways that no one could have predicted. The image Craigs captured wasn't just an anomaly, it was the beginning of a new chapter in the study of interstellar objects. And as the object drew closer to Earth, it seemed to be revealing its secrets, one piece at a time. By the time 3I Atlas reached its closest point to the Sun, in late October 2025, astronomers were on high alert. They knew that the Sun's radiation would have a profound effect on the comet's behaviour. Comets, by their very nature, are chaotic objects. They are essentially icy bodies, dirty snowballs as they're often described, that shed dust and gas as they get close to the Sun. This release of gas forms the coma, a cloud of gas and dust that surrounds the nucleus, and the tail, which points away from the Sun due to the solar wind pushing the material outward. But 3I Atlas wasn't following the rules. At 1.4 astronomical units, about the same distance as Mars' orbit, the object should have been hit with a flood of solar radiation strong enough to trigger a process known as sublimation, in which the comet's ice turns directly into gas. As the ice vaporized, it should have produced a visible tail, a display of chaos and fragmentation. Yet, as the data poured in, it became clear that this wasn't happening in the expected way. Comets are notorious for being messy, unpredictable. The heat of the Sun usually causes their icy surfaces to vaporize in an irregular manner, creating jets of gas that shoot out from various spots on the comet's surface. These jets are not only chaotic in nature but also in direction. Sometimes they appear to erupt from the side facing the Sun, and sometimes from the shadowed side. The sublimation of volatile materials is far from uniform, and the result is often an erratic, turbulent coma. Yet 3I Atlas showed none of this. It didn't break apart under the Sun's intense heat, nor did it experience the expected chaotic outbursts. Instead, the object remained intact and stable. The professional data confirmed that the nucleus of the comet was still there, surrounded by a faint diffuse coma, but it wasn't showing signs of typical cometary activity. There were no large jets of gas erupting from its surface. There was no fragmentation, no sharp increase in brightness from sublimation. This stability was not just unexpected, it was downright puzzling. Comets are supposed to behave like time bombs, gradually breaking apart and dissipating in the harsh heat of the Sun. Instead, 3C Atlas acted like it was in control of its situation, maintaining a perfect trajectory even as it passed so close to the Sun. Its surface seemed to remain solid, without the expected chaotic disintegration. The scientific community couldn't explain it. What made this interstellar object so different from the hundreds of comets we've studied before? Could this be some anomaly, a once-in-a-lifetime event, or was something more profound going on? At the time, many scientists chalked it up to the unique circumstances surrounding 3I Atlas's journey. After all, it wasn't from our solar system. It was an interstellar visitor, a cosmic traveller that had likely been in space for billions of years. Maybe the conditions under which it formed were different from those of our solar system's comets. But the more the data came in, the less this explanation seemed to fit. Because 3 Atlas wasn't just surviving the Sun, it seemed to be thriving. It wasn't falling apart under the Sun's radiation, it was holding itself together, maintaining an almost eerie precision. This wasn't just a comet behaving oddly, it was an object that was breaking the rules of physics as we understood them. The solar scientists who had been watching closely began to ask the unthinkable. What if 3I Atlas wasn't a comet at all? What if it was something else entirely? Something that defied the natural laws we had relied on to explain the behaviour of celestial objects? The more they examined it, the more they realised that they had no answers, only more questions. October the 30th, 2025, marked the most anticipated moment in the story of 3I Atlas. It was set to reach perihelion, its closest approach to the Sun. At a distance of just 1.4 astronomical units, it was poised to enter the inner solar system, passing just beyond Mars' orbit. For most interstellar objects, this would be a one-way ticket to disintegration. The intense solar radiation would vaporize their volatile components, and they would either fragment into dust or disintegrate completely. That's the way comets behave. It's a predictable cycle that has been observed time and time again, but this time, something different happened. As 3I Atlas approached perihelion, astronomers watched eagerly, expecting the usual display of cometary chaos. Jets of gas spewing from its surface, clouds of debris trailing behind it, and perhaps the faint signs of fragmentation. But instead, 3 Atlas did something that defied everything they knew about how comets interact with the Sun. Rather than the violent outgassing expected from an icy body nearing the Sun, 3 Atlas maintained an almost eerie stability. As the Sun's heat bathed its surface, it should have triggered the sublimation of ice, water vapour, carbon dioxide and other gases, creating the characteristic coma and tail that comets are known for. But 3 Atlas did not display this typical chaotic behaviour. it remained remarkably intact, almost unnaturally so. The object's trajectory, too, was strangely precise. Comets often show small deviations in their paths due to the uneven jets of gas propelling them in slightly different directions. These deviations are not just a result of solar wind or gravitational forces, they're a natural consequence of the outgassing from the comet's surface. Yet 3I Atlas appeared unaffected by such forces, holding its course with disturbing accuracy as it passed closest to the Sun. This behaviour caught the attention of scientists across the globe, especially those at NASA and ESA, who were closely monitoring its passage. Their expectations were simple. 3I Atlas, like every other comet, should have shown erratic behaviour as it neared perihelion, but instead the object remained under control. Its movements were measured and deliberate, as if responding to the Sun's influence rather than reacting to it. The official images released by professional observatories were a mix of standard cometary observations, bright comas, visible tails. But these images failed to capture the strange precision with which 3I Atlas approached the Sun. Unlike other comets, which fragment or show irregular motion, 3I Atlas was behaving like a well-engineered object, one that was deliberately responding to its environment. One of the most striking aspects of this close encounter was the brightness of 3I Atlas. Comets typically brighten steadily as they approach the Sun, their gas and dust clouds reflecting sunlight. But 3I Atlas's brightness didn't increase in the expected manner. Instead of a gradual rise, there was a sudden burst of brightness, a sharp spike that appeared just before perihelion. This was followed by a period of stabilization, as though the object had absorbed the solar radiation and was using it in some manner. The solar scientists were particularly intrigued by this. What they were witnessing didn't fit the standard model of cometary behaviour. The spike in brightness wasn't consistent with the typical outgassing seen in other comets. There was no corresponding release of water vapour or dust. The light came from somewhere else, and this was the first indication that 3I Atlas wasn't behaving like a typical comet. In fact, the more scientists observed, the more they began to wonder whether 3I Atlas was actually harvesting energy from the Sun. Instead of vaporizing under the solar radiation, it seemed to be absorbing and redirecting that energy. The spikes in brightness and the unusual stability of the object suggested that it was drawing power from the Sun, rather than just passively reacting to its heat. This realization raised further questions. Could 3I Atlas be some sort of interstellar probe or craft designed to interact with stellar energy in a way we've never seen before? Could this object be using the Sun as a power source, collecting and converting solar radiation to fuel its journey through space? As October drew to a close and 3I Atlas passed closest to the Sun, the mystery deepened. What had been an ordinary cometary encounter turned into something far more complex. The data was beginning to suggest that 3I Atlas was more than just a comet. It was an enigma, an object that appeared to be harnessing solar energy in a way that no natural object had ever done before. Astronomers were left with more questions than answers. Was this just an extraordinary comet? Or had humanity stumbled upon something far more incredible, something designed with purpose by an intelligence beyond our comprehension? As the object continued its journey through the solar system, the possibilities grew ever more unsettling. As 3I Atlas sailed through the solar system, the data began to reveal anomalies that no one could quite explain. Up until this point, the object had been behaving in ways that strayed from the typical cometary playbook. But what happened after its perihelion, when the object was past its closest approach to the Sun, made the scientific community sit up and take notice. Normally, after a comet's closest approach to the Sun, its activity begins to fade. The solar radiation, which had previously vaporized the comet's volatile materials, diminishes as the object moves away from the Sun. The coma and tail should shrink, and the object's brightness should decrease. But 3I Atlas wasn't following this script. Instead of fading into the background, 3I Atlas's activity intensified. The tail, which had been a faint streamer of gas and dust, grew in size and brilliance. It was as if the object was absorbing the Sun's energy and continuing to release it even as it moved farther away. This wasn't the behaviour of a comet that had passed its peak activity. This was something different. Observatories around the world were capturing strange data. 3I Atlas was exhibiting consistent and unexpected acceleration away from the Sun. The acceleration was small, but it was there, and it wasn't the result of the typical outgassing. Comets usually show irregular accelerations, caused by the uneven release of gas from their surface. But 3I Atlas's movement was steady, clean, and measured, almost as if it was under control. Something was directing this object, something that was not typical of a comet's behaviour. The most unsettling aspect of this was the fact that 3I Atlas had passed the Sun and was now on its way out of the solar system. It was moving at a high velocity, but the data showed no signs of a typical comet's disintegration. Instead, it remained solid, stable, and active. Its tail remained visible, and its jets continued to emit material in a highly organised manner. This raised more questions than answers. What could be causing 3I Atlas to behave this way? Was it possible that the object was not just a comet, but something else entirely? Something engineered? By the time 3I Atlas reached the outer edge of its solar encounter, it was clear to the scientific community that this object was not behaving like any comet they had ever observed. As the interstellar traveller moved past its closest point to the Sun and continued its outbound journey, the expected patterns of activity didn't emerge. In fact, the data revealed more about the object than anyone could have imagined, and it only deepened the mystery. Comets, as we know them, tend to be unruly and chaotic when exposed to the Sun's heat. Their icy bodies begin to vaporize, forming a coma, a cloud of gas and dust, that often spills out into the space surrounding the comet. The result is usually a tail made up of material being pushed away from the nucleus by the solar wind. This is the classic comet behaviour that has been well understood for centuries. The closer a comet gets to the Sun, the more active it becomes, shedding debris as its ice turns to gas. But 3I Atlas was different. As the comet passed its perihelion, the Sun's radiation should have caused a massive increase in the sublimation of volatile materials, water, carbon dioxide, and other gases, creating a visible tail of gas and dust. However, 3I Atlas didn't just release material in a typical disorganized fashion. Instead, its behavior remained eerily controlled. While there was a faint emission of gas and dust, it was highly structured, unlike the chaotic jets we typically associate with comets. This anomalous behavior was especially noticeable in the object's tail. Rather than the traditional tail of dust and gas that forms behind most comets, 3I Atlas showed a more defined, persistent structure. Its tail wasn't dissipating or breaking apart. It was steady and almost unnaturally aligned. But that was only the beginning of the strangeness. The most puzzling feature of all was the antitail, an unusual formation that seemed to point directly toward the Sun. Comets are supposed to have tails that point away from the Sun, pushed by the solar wind. The material in the tail should always be repelled by the heat of the Sun. But 3I Atlas's antitail behaved in precisely the opposite way, suggesting that something within the object was actively controlling its emissions. This feature wasn't just an optical illusion created by the viewing angle, as some initially speculated. It appeared in multiple images taken from different positions as Earth moved in its orbit. The antitail remained visible, a persistent feature that pointed directly toward the Sun. This defied all known physics. What kind of object would emit material in such a way, creating a tail that pointed in the opposite direction from the Sun? For weeks, astronomers had tried to come up with an explanation. The most logical assumption was that the object was a comet, and its peculiarities were due to unusual activity. But no amount of recalculating or adjusting the models seemed to provide a satisfying answer. No comet they had ever studied had displayed this kind of behaviour. It was during this period of confusion that the possibility of something more extraordinary began to take shape. What if 3I Atlas wasn't just a comet? What if it was something engineered? Perhaps a probe, a spacecraft, or some kind of cosmic machine designed to behave in this unusual manner. The idea of an artificial object hurtling through space was a difficult one for scientists to entertain. For years, the scientific community had been firmly rooted in the understanding that comets, asteroids, and other celestial bodies were natural objects formed from the leftover material of star formation. The idea that an object from outside our solar system could be engineered, perhaps by an extraterrestrial intelligence, was not something they were ready to accept. But the more the data came in, the harder it was to dismiss the possibility. It wasn't just the anti-tail that was raising questions. It was the overall structure of the object, the way it held together after passing so close to the Sun. The behaviour of 3I Atlas suggested a level of control that no comet should have. This was not a natural body responding to solar radiation. It was an object that seemed to be deliberately managing its energy, its trajectory, and its emissions. This realization sent shockwaves through the scientific community. What if we weren't dealing with just another comet from the far reaches of space? What if 3I Atlas was something more? Something that had been engineered to survive and thrive under conditions that would destroy any natural object? The idea that this could be an artificial object was still highly speculative, but as more data came in, it began to seem less far-fetched. The anti-tail, the controlled jets, the object's ability to maintain stability, even after its closest approach to the Sun, all of these features pointed to something beyond a natural comet. As December 19th, 2025 approached, 3I Atlas continued its journey through the solar system, leaving astronomers with more questions than answers. Was it just an unusually active comet, or was it something more profound? The mystery deepened with every new observation, and the scientific community found itself grappling with the unsettling possibility that they were witnessing something far more complex than they had ever imagined. As 3I Atlas continued its journey through our solar system, astronomers began to realize something crucial. The object wasn't just surviving the Sun's harsh radiation, it was actively using it. Unlike a typical comet, which would gradually disintegrate and fade as it moved past the Sun, 3I Atlas was maintaining its structure and showing signs of even more activity as it passed closest to our star. Comets are known to be sensitive to solar radiation. As they approach the Sun, the heat causes the icy material in their cores to vaporize, creating jets of gas and dust that form a coma and a tail. This sublimation process is a natural consequence of the heat, and it's what makes comets so fascinating to study. However, 3I Atlas didn't behave like a typical comet. Instead of disintegrating or fading after its perihelion, it seemed to be drawing energy from the Sun, using that energy to power its own emissions. This was a critical observation, one that would set 3 Atlas apart from all other known comets. The way the object maintained its structure, its steady progression through space, and its ability to continue emitting material in an organized manner all suggested that it was harnessing solar energy rather than simply reacting to it. Comets don't do that. But 3I Atlas seemed to be breaking the rules. Astronomers were initially puzzled. The object's brightness didn't increase in the expected manner as it neared the Sun. Instead, it remained relatively stable, then experienced a sudden spike in brightness just before perihelion. This wasn't the gradual increase in light that is typical of comets as they near the Sun. Instead, it was a sharp burst of energy, almost as if the object was absorbing solar radiation and converting it into something else, something more purposeful. The most intriguing possibility was that 3I Atlas was using solar radiation in a way that resembled the behavior of a solar sail. Solar sails are an emerging technology that use radiation pressure to propel spacecraft. They work by reflecting sunlight off a large, thin, reflective surface, generating thrust without the need for traditional fuel. This technology is still in its infancy, but it's based on a simple concept. If a material can reflect sunlight, it can use that radiation to push itself forward. Could 3I Atlas be using solar radiation in a similar manner, like a solar sail? The data suggested that this might be the case. As the object moved closer to the Sun, it seemed to absorb the solar energy and then release it in the form of jets. These jets weren't random or chaotic. They were structured and organized, pointing in specific directions. This kind of behavior suggested that 3I Atlas was not just a passive object reacting to its environment, but one that was actively controlling its energy output. If 3I Atlas was, in fact, using solar energy as fuel, it would be the first interstellar object known to do so. This raised even more questions. How could an object from another star system, formed in conditions completely different from our own, develop such an advanced capability? Was this a natural process, or was there some intelligence behind it? This theory of 3 Atlas as a solar-powered object fit with the strange behavior astronomers had been observing. It wasn't just absorbing energy, it seemed to be actively using that energy to propel itself through space, much like a spacecraft using a solar sail. The idea of an interstellar probe designed to harness and use solar radiation seemed more and more plausible as the data continued to pour in. In the weeks leading up to its closest approach to Earth, 3I Atlas became more than just a comet. It became a cosmic mystery, one that was forcing scientists to reconsider everything they knew about the behavior of interstellar objects. Could we be witnessing the first example of a technology that uses stars as refueling stations, Or was 3I Atlas something far more complex, something designed to operate in ways that defy our understanding of physics? As December 19th, 2025 drew closer, the world waited to see what more would be revealed about 3I Atlas, and with each passing day, the mystery only grew deeper. As we draw to the end of this deep dive into the mystery of 3I Atlas, the questions we've explored only seem to multiply, leaving us on the edge of a cosmic cliff, waiting for the final revelation. December the 19th, 2025 is fast approaching, and with it the climax of 3I Atlas's journey through our solar system. But what will happen next? The possibilities are vast, and with every new piece of data, the enigma grows even more intriguing. We've examined its arrival from another star system, its strange behaviour as it approached the Sun, and the unsettling anomalies that have surfaced with each passing day. From its unexpected stability to the anti-tail that pointed back toward the Sun, 3I Atlas has baffled the scientific community at every turn, and yet, as we piece together the clues, it's clear that this object is not just a comet. It's something much more complicated, something that seems to defy all our expectations. We've also seen how the object behaves as it draws power from the Sun. Unlike the typical comet that vaporizes and fades, 3I Atlas seems to be harnessing solar energy, almost as if it's using the Sun as a fuel source. Could this be a deliberate design? Is it possible that we are witnessing the first signs of extraterrestrial technology, something engineered to harvest energy from stars? The thought is both exhilarating and unsettling. With every new piece of information, the mystery deepens. What are we really looking at? Is 3I Atlas a comet that simply doesn't behave like one? Or is it something entirely beyond our understanding? The anomalies continue to stack up, and the more we try to fit them into our current models, the more we realize that our understanding of space, of comets, and perhaps of technology itself may be woefully incomplete. And what about its future? As 3I Atlas continues its journey away from the Sun, past its closest approach to Earth, it will eventually make its exit from our solar system. But will we ever see it again? Is this just a fleeting visitor, a cosmic anomaly that passed through our corner of the galaxy, or is there something more to its trajectory? The fact that this object came from another star system raises more questions than answers. What if it's not just passing through? What if 3I Atlas is just the first of many objects from distant stars that will one day enter our solar system? What if, one day, we find ourselves surrounded by a fleet of interstellar travellers, each carrying its own secrets? For now, we can only wait. The final data from December 19th will give us a clearer picture of what 3I Atlas truly is, but no matter what we discover, the implications will be profound. Whether it's a natural object that bends the rules of comet physics, or a piece of technology designed by an alien intelligence, one thing is certain. 3I Atlas is challenging our understanding of the universe. As we look toward the future, we must ask ourselves, what if this is only the beginning? If 3I Atlas is a sign of something greater, something beyond our comprehension, then what else might be out there in the dark, waiting to be discovered? Could there be other objects like it, travelling through the vast expanse of space, silently making their way toward us? In the coming days and weeks, we'll continue to monitor 3I Atlas's journey, waiting for the next piece of the puzzle to fall into place. Will the data confirm our suspicions, or will it lead us down a path we never expected? Whatever the case may be, one thing is clear. We are living through a moment of discovery that could change the way we view our place in the universe. Thank you for joining me on this journey through the mystery of 3I Atlas. If you found this exploration as fascinating as I did, please consider subscribing and hitting the like button. The world of space exploration is ever-changing, and with every new discovery, we take another step closer to understanding the cosmos. Let me know your thoughts in the comments. What do you think 3I Atlas really is? Could it be a piece of technology, or is it just a weird comet? I'd love to hear your theories. Remember, we're only scratching the surface of what lies out there. The answers may not come easily, but the search for them is what makes this journey so thrilling. And as always, stay tuned, because the next chapter in the story of 3I Atlas is just around the corner. We may not have all the answers yet, but we're getting closer. Until next time, keep looking up.